Good morning to everyone. I am Dr.A.Siva Kumar, Assistant Professor CMRCET. Now, in last section, we have to discuss the topic in the multivariable calculus, the limits and continuous and their problems. Now, today's section, we will discuss the concept in the third unit. Partial differentiation and its applications. Today we have to discuss the concept. We will discuss the concept partial differential equations. In this chapter, we introduce the notation of the functions of several variables, that is, the functions of two or more variables can be discussed in the partial differential equation. That means the multivariable calculus. Okay, now what is the definition of partial differential equation? Now let z is equal, the function z is equal f of the x comma y variables be a function, that is the two variables x and y, the function of z, two variables, that is x and y. Then the limit extends to 0 f of x plus delta x comma y minus f of x comma y by delta x. If it is exist, then it is said to be is said to be partial derivative or partial differential coefficients of the z with respect to x. Then it is denoted by dou z by dou x or dou f by dou x. So generally the partial derivatives, it is denoted by dou z by dou x or dou f by dou x. So this is a partial differentiations. Z is equal to f of, that is a multivariable calculus, x comma y, there are the function of the two variables x and y. Then the limit extends to 0 f of x plus delta x comma y minus f of x comma y by delta x. It is exist, then it is said to be a partial derivative or partial differentiation. Now generally it is denoted by dou z by dou x or dou f by dou x. Okay, now the note 1 is, if the partial derivative in partial derivative of z is equal to f of x comma y with respect to x and y is a constant, and y variable is a constant. With respect to y and x is really constant. Okay, in the partial derivative, this is the one important note. And second one is, in general, first order partial derivative in the first order partial derivative, dou f by dou x and dou f by dou y is a functions of x and y. It is can be repeatedly to get a higher order partial derivative. It is a continuously derivatives. Now differentiate repeatedly to get higher order partial derivative. Higher order partial derivative. Now the higher order partial derivative is represent dou f by dou x. Third one, higher order partial derivative dou square f by dou x square equals dou by dou x of dou f by dou x. This is higher order derivatives. So dou f by dou x is the first derivative. Again with respect to x, dou square f by dou x square, this is second order derivative. Now the similarly, dou square f by dou y square equals dou by dou y of dou f by dou y. So this is the second order partial derivatives. Okay. And the next one, in the partial derivative, higher order derivative, dou by dou x, dou square f by dou y square equals is a referent for the dou cubed f by dou x dou y square. And similarly, dou by dou y, dou square f by dou x square equals dou cubed f by dou y dou x square. And now dou by dou y into dou f by dou x equals dou square f by dou y dou x. And now this is the second order. First one is the third order derivatives. Okay. Dou by dou x dou f by dou y equals dou square f by dou x dou y. So sometimes we also use the symbols f x comma x, that is the second order derivative for dou square f by dou x square. At the same way, dou f y for dou square f by dou y square. And also f xy equals is referent for the dou square f by dou x dou y and etc. So this is the second order partial derivative. Okay, this is the higher order or partial derivative. And the third order partial derivatives, this is the definition of the partial derivatives is a represent for dou z by dou x or dou f by dou x. In the first order partial derivative, dou f with respect to x, y is a constant. Similarly, with respect to y and x is a constant. Okay. Now, generally, higher order is nothing but a second order and the third order is nothing but higher order partial derivative. Okay. This is a referent for the second order partial derivative. Similarly, third order partial derivative. And also sometimes we can also use the symbols. Fxx is nothing but the function of xx is nothing but second order partial derivative. Dou square f by dou x square. And similarly, fxy is nothing but dou square f by dou x and dou y. Okay. However, we note that fxy is equal fyx. We note that fxy is equal to fyx, etc. So that means dou square f by dou x dou y is equal to dou square y into dou x. So these are equal. So sometimes we note that. See, this is the first order partial derivatives and second order partial derivatives. Now, how to solve the problems of partial derivatives? Okay, find first order and second order partial derivatives of first order and second order partial derivative of ax square plus 2hxy plus by square. There are two variables and verify find the first order and second order partial derivative of the function ax square plus 2hxy plus by square. It depends on the variables x and y. Now, and verify dou square f by dou x dou y equals dou square f by dou y dou x. So now the given function, now okay, this is the first order, second order partial derivative, the given function, and also is a verify the second order derivative, dou square f by dou x dou y equals dou square f by dou y dou x. Okay, now given function, it is a two variables on there, f of x comma y is equal to ax square plus 2hxy plus by square. Okay, then find the first order partial derivative, that means with respect to x and with respect to y, dou f by dou x. Dou f by dou x with respect to x, y will be constant. Okay, you know that 2ax plus 2hy. So d by dx of x square, 2x, that is a 2ax. A and b is a constant. And 2h is with respect to dou x by dou x is 1 and y is a constant. Plus b is a constant and y is a constant. D by dx of constant is a 0. So that's why dou f by dou x 2ax plus 2hy. And the same way second order dou square f by dou x square. Again with respect to x, dou x by dou x is nothing but 1 and 2hy is a constant. D by dx of constant is a 0. With respect to x, y is a constant. That is a 2a. Since y is a constant. Y is a constant. Again, dou f by dou y with respect to y. With respect to y, x is a constant. With respect to y, x is a constant. Now, 2hxy plus 2by. So, again with respect to y, so 2h x is a constant because x is a constant. That's why d by dx of constant first term 0. 2by. So, that is nothing but 2b. So, here x is a constant. X is a constant. Okay. So, this is a find the first order and second order partial derivatives. Now, we can find the second order partial derivative dou square f by dou x dou y equals dou by dou x of dou f by dou y equals dou by dou x of dou by dou y, the value is 2hx with respect to y plus 2by. So here with respect to x, that is a constant, that is a 2h, y is a constant, that is the second term will be 0. So similarly, dou square f by dou y dou x is equal dou by dou y into dou f by dou x. So dou f by dou x with respect to x, the value is dou by dou y. You know that 2ax plus 2hy. So with respect to y, x is a constant. So that's why the value is a 2ax is a 0. Dou by dou y is nothing but 1, therefore 2h. So you can observe that, therefore dou square f by dou x dou y equals dou square f by dou y dou x. So is verified. Okay. So this is the given one function is two variables of x, y, x square plus 2hxy plus by square. And now find out the first order and second order partial derivative, and also can verify that dou square f by dou x dou y equals dou square f by dou y dou x. So the given function with respect to dou f by dou x and y is a constant. We can find the second order derivatives. Dou f by dou y with respect to y and x is a constant. Now we can get the second order, the both are same. Therefore 2h is equal to s. Therefore it is a verified. So this is the first problem. You can find out the partial derivatives. Okay. Now the second problem, if w equals y minus z, w is a one function, z minus x and x minus y. So here there are three variables are there, that is a multivariable. Two or more variables is nothing but multivariable calculus. And find the value of dou w by dou x plus dou w by dou y plus dou w by dou z. So we can determine the w value is y minus z, z minus x, x minus y. Find the value of dou w by dou x plus dou w by dou y plus dou w by dou z. So now the solution, now the given function w equals, the w equals y minus z, z minus x, x minus y. Now dou w by dou x equals with respect to x. Now with respect to x, that is the UV form, yz is a constant. With respect to x, yz is a constant. So that's why yz is a constant. Y minus z into dou by dou x of with respect to x is represent for z minus x into x minus y. So here with respect to x, since y and z are constants, z are constants. Okay. So you can represent for that is a UV form. UV form. So d by x of UV form is nothing but d by x of UV now is the represent u dou v by dou x plus v dou u by dou x. Okay. Now y minus z into, you can represent the values z minus x minus x plus y. So now the simplify y minus z into y plus z minus 2x y minus z. Now the simplify of dou w by dou x equals y square minus z square minus 2x into y minus z. So that is equation 1. So we can represent for the UV form dou w by dou x value is y square minus z square minus 2x into y minus z. So the similarly we can find the dou w by dou y. So dou w by dou y equals z minus x into dou by dou y of y minus z into x minus y. So here with respect to y, z and x are constant. Okay. So now we can represent for debit x of UV form. Same in the previous of the concept dou w by dou x. Now we can get with respect to y of the UV form, the value is y minus z into dou by dou x of x minus y is nothing but minus 1 plus x minus y into with respect to y, dou by dou y is nothing but 1, remaining constant is 0. Okay, so now the value is z minus x into x minus 2y plus z. Now simplify dou w by dou y is equal to z square minus x square minus 2y into z minus x. So that is equation 2. So similarly, we can find the dou w by dou z. Okay, with respect to z and xy is a constant. Okay, now x minus y into dou by dou z of y minus z into z minus x. So with respect to z, similarly at z, x and y are constants. So again you can apply for the UV form x minus y into, now with respect to minus 1, dou z by dou z is nothing but minus 1, y is a constant 0 into z minus x plus y minus z into 1. So now the value is dou w by dou z equals x square minus y square minus 2z x minus y. That is the third equation. So we can adding the 1, 2, 3. Now we can get adding equations, 1 plus 2 plus 3 gives, we get now we can what the value dou w by dou x, dou w by dou y plus dou w by dou z. You know that equation 1 dou w by dou x is value y square minus z square minus 2x into y minus z plus the second one dou w by dou y z square minus x square minus 2y into z minus x plus third one dou w by dou z x square minus y square minus 2z into x minus y. So we can multiple 2xy minus 2xz again 2yz plus 2yx and so on, all values will be 0. Simplify the, after simplification all values is 0. So therefore dou w by dou x plus dou w by dou y plus dou w by dou z equals 0. So that is a solution. For the second problem, we can determine the z value. That is the three variables are there, x, y, z. In the first problem is the two variables x, y. In the three variable w equals. So that is the three variables x, y, z. W is a function. Okay. So this is the second variables of the find of the partial derivative, and the third was the third variable of x, y, z in the second problem. Okay. And the next one, in the third problem, if u is equal log x cubed plus y cubed plus z cubed minus 3xyz. So there, here the function is a u function is a three variables x, y, z. Okay. Now prove that dopa by dou x plus dopa by dou y plus dopa by dou z whole square into u is equal to minus 9 by x plus y plus z whole square. The result is minus 9 by x square plus y square plus z square whole square. So the given function is, now the solution, the three variables, the given function u is equal to log x cubed plus y cubed plus z cubed minus 3xyz. Okay, now find the dou u by dou x. Now with respect to, so d by dx of log x is nothing but 1 by x into dx by dx. So d by dx of log x is a 1 by x into dx by dx. So 1 by x cubed plus y cubed plus z cubed minus 3xyz into again d by dx of x cubed plus y cubed plus z cubed minus 3xyz. So here with respect to x, y and z are constants. So that's why d by dx of x cubed 3x square minus 3yz. So here y and z, y, z are constants. Y, z are constants. So dou u by dou x equals 3x square minus 3yz by x cubed plus y cubed plus z cubed minus 3xyz. So now the similarly find dou u by dou y equals again d by dx of log x is nothing but 1 by x into dx by dx. So 1 by x is x cubed plus y cubed plus z cubed minus 3xyz by into again d by dx of x cubed plus y cubed plus z cubed minus 3xyz. Now 3y square minus 3xz. So with respect to y, here x comma z are constants. Okay. So similarly, you can find that dou u by dou z. With respect to z, x and y are constants. So now 3z square minus 3xy by x cubed plus y cubed plus z cubed minus 3xyz. So here x comma y are constants. Here x, y are constants. So now adding the both dou u by dou x plus dou u by dou y plus dou u by dou z equals, denominator is the same. Now 3x square minus 3yz by x cubed plus y cubed plus z cubed minus 3xyz, denominator are same, plus dou u by dou y value is 3y square minus 3xz by x cubed plus y cubed plus z cubed minus 3xyz. And now the third variable dou u by dou z, the value is 3z square minus 3xy by x cubed plus y cubed plus z cubed minus 3xyz. So adding this, now the simplify equals 3 into x square plus y square plus z square, the common, minus xy minus yz minus zx by, in the denominator x plus y plus z is a common. Now we can get x square plus y square plus z square minus xy minus yz minus zx. Okay, the numerator denominator will be cancelled. Now we can get the value is 3 by x plus y plus z. So that is equation 1. Okay, now what is a LHS? Dou u by dou x plus dou u by dou y plus dou u by dou z. The result is 3 by x plus y plus z. Now the result is, you can find now, the result is, you can find the result dou by dou x plus dou by dou y plus dou by dou z whole square into u is equal to. Okay, now you can write as dou by dou x plus dou by dou y plus dou by dou z into o square is nothing but, again we can write as dou u by dou x plus dou u by dou y plus dou u by dou z. So we can write as dou by dou x plus dou by dou y plus dou by dou z whole square into u is equal. Now we can write as dou by dou x plus dou by dou y plus dou by dou z into dou u by dou x plus dou u by dou y plus dou u by dou z. Okay. Now the from equation 1, from 1, we have already find out the value recently. Okay, dou by dou x into plus dou by dou y plus dou by dou z into, now the value is 3 by x plus y plus z. Okay, now we can find that dou by dou x into 3 by x plus y plus z plus dou by dou y 3 by x plus y plus z plus dou by dou z 3 by x plus y plus z. Now the value is minus 3 by x plus y plus z whole square with respect to x, divided x of 1 by x minus 1 by x square. So x is nothing but x plus y plus z. Again minus 3 by x plus y plus z whole square minus 3 by x plus y plus z whole square. Okay, now the result is minus 9 by x plus y plus z whole square. Therefore, what is LHS? Dou u by dou x plus dou by dou y plus dou by dou z whole square into u is equal to minus 9 by x plus y plus z whole square. Hence the proved. Hence, proved. The result is proved. Okay. Yes. And now one more problem we can discuss in the partial derivatives. If u is equal to y by z plus z by x, then show that x dou u by dou x plus y dou u by dou y plus z dou u by dou z equals 0. So, solution, given u is equal to y by z plus z by x. So, we can find the dou u by dou x, dou u by dou y and dou u by dou z. Okay. Now, equals 0. The result is 0. Dou u by dou x equals, with respect to x, obviously yz is a constant, that is a 0 plus z into d by x of 1 by x, nothing but 1 by x minus 1 by x square, like that, minus z by x square. Now the second one, similarly, dou u by dou y is equal, with respect to y, x and z is a constant, so 1 by z into 1, the remaining terms is 0 equals 1 by z. Now similarly, dou u by dou z equals, with respect to z, xy is a constant, so that's why y into minus 1 by z square. So d by dou z of 1 by z is nothing but minus 1 by z square plus 1 by x into 1. So now the value is minus y by z square plus 1 by x. Okay, now x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals, now the value of x into, yes, in the recently we can find that the dou u by dou x value is minus z by x square plus y into 1 by z plus z into minus y by z square plus 1 by x. Now the value is minus z by x plus y by z minus y by z plus z by x. Now the value will be 0. So therefore, x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals 0. Hence the proof. Hence the proof. So the first problem is, find the first and second order partial derivative and also can find the second order derivatives. Dou square f by dou x dou y, dou square f by dou y dou x is a verify, both are same. Okay, second one, if the another variable w is a one function, y minus z, z minus x, x minus y. Now we can find the result, find the value dou u by dou x plus dou u by dou y plus dou u by dou z. Now we can get the result is 0. And the third one is u is equal to log x cubed plus y cubed plus z cubed minus 3xyz. Now we have to prove that dou u by dou x plus dou u by dou y plus dou bar by dou x, dou bar by dou y plus dou bar by dou z whole square into u is equal to minus 9 by x plus y plus z whole square. And last one is u is equal to y plus z plus z by x. Then show that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z. Now the result is 0. So today's session We will discuss the concept. We have to discuss the concept for partial derivatives with the two or more variables. Okay. Okay. Thank you. Thanks everyone.